Hello everyone, today we're going to be working on example 6.4-2, and this example is saying that for the truss given below, use the method of sections to evaluate the force in bars GF, CF, and CD. So when doing a problem like this, the first thing that you want to do is determine where that cut is going to go through that truss, and usually you want that cut to be going through all of those bars that you have to determine or identify their force. Here for this example, the cut is already given to us, but they do this cut AA because it passes through GF, CF, and CD. So that's why they did the cut right there. From there, we would have to evaluate which side would be easier to work with to determine the forces of those bars. So if I were to take a look on the right side of the truss, we could see that we would be dealing with one force and one unknown reaction. Meanwhile, if I were to deal with the left side, we know that we would be dealing with one force and two unknown reactions, which is why I would be, in my opinion, I'd choose the right side since we would just have to determine one unknown reaction as compared to the left side, we would have to determine two unknown reactions. So with that, we know that we have to determine the value of our reaction right here. So because of that, that's gonna be my first step. So we know that this reaction right here has to be a vertical reaction since we have a roller. I'm gonna assume that that reaction is gonna be reacting upwards. So we're gonna call it E sub Y. And since I'm trying to determine just for E sub Y, and I'm not trying to find the values of these two reactions here, what I'm going to be doing is I'm going to be taking the sum of the moments about point A, because if I were to do it about point A, we know that these two unknown reactions would not be creating a moment, and it would only simply be these three, giving us the value for E sub Y, which is the only one that we need to know to work with the right side of the truss. So that's what I'm going to do. So sign convention. So first step would be calculating E sub y. So sign convention counterclockwise is positive. The sum of the moments about point A have to equal 0. So from there we have this 5 kilonewtons that's acting downwards. So we know that's going to be creating that clockwise moment, meaning a negative moment. So we have a negative moment is equal to the force times the distance. So with a force of 5 kilonewtons times the distance of from here to here, it's given to us that it has a distance of 8 meters, so 8 meters. From there, we have another reaction on the right side of that point going downward. So once again, we're going to be having that clockwise moment, meaning negative moment, with a force of 3 kilonewtons. And this time with a distance of, we know that from here to here, there's a distance of 12 meters. So times 12 meters. And then from there, we have E sub y. I assume that it's going to be acting upwards. So since it's upwards to the right, we know it's going to be creating that counterclockwise moment, meaning a positive moment. So positive moment of our force, that's what we're trying to determine. So E sub y times the distance. We know that from here to here, we have a distance of 16 meters. So times 16 meters. We know that all of that has to equal 0. So from here, if we were to solve for E sub y, we would end up getting that our reaction E sub y has a value of 4.75 kilonewtons. Since we got a positive number, that means that we assumed correctly, so we do know that that reaction will be going upwards. So now that we have found the value of E sub y, I'm simply going to come over here, just replace it, 4.75 kilonewtons. So now we're going to proceed to using the method of sections to determine the forces of these three bars right here. So the next step would be drawing out the right side of the truss that you're going to be working with. As you guys could see, I already drew it out here. We have our bar EF, our bar DE, our reaction right here, which I can now replace with the value, 4.75. From there, we have our force of 3 kilonewtons right here. And then from there, we have our three members, our three bars that we're trying to determine their force. I'm going to assume that they're in tension for right now. Then as we go solving them, if we get a positive number, that means we assumed correctly. And if we got a negative number, that means that they're actually going to be in compression. And then from there, we have dimensions on the figure that's already given to us. So now the next step would be using the method of sections. So I'm gonna go ahead and just make this a bit smaller. There we go. So the second step would be using method of sections. So my first step would be I'm going to be taking the sum of the moments about point F, and that is going to be because the force of the bar C of F and the force of the bar G of F will not be creating a moment about that point, meaning that just the force of the bar CD would be creating a moment with the two other forces, meaning that when we take the sum of the moments about point F, we would be able to solve for the force of the bar CD. So that's why I'm going to do the sum of the moments about point F. So from there, we have our 4.75 kilonewtons. It is going upwards and to the right about that point. So we know it's going to be creating that counterclockwise moment. So that means a positive moment with a force of 4.75 kilonewtons times the distance of, we know that from here to our point F, there's a distance of 4 meters. So times 4 meters. From there, we have our 3 kilonewtons. I'm so sorry, I forgot about this. Our 3 kilonewtons will also not be creating a moment since it is parallel to that point. So our 3 kilonewtons will also not be creating a moment. I'm so sorry that I said that it would. I'm so sorry, you guys. It will not be creating a moment since it is a parallel to that point. Now, if like the force of the bar CD, now we do know that that one will be creating a moment. So now moving on to the force of the bar CD, it is below that point going to the left since I assume that it's going to be in tension. So for this specific example, it is going to the left. That means it's going to be creating a clockwise moment, meaning a negative moment. So we have a negative moment of a force. We're trying to determine that force. So force CD times a distance of, we know that from here to here, there's a distance of 4 meters as well. So times 4 meters equals 0. So from here, if we were to determine the value of the force of the bar CD, we would end up getting a value of 4.75 kilonewtons. And since we got a positive number, that means that we assumed correctly. So it is true that it will be in tension. So with that, we already determined uh, the force of a member or a bar of the bar CD. So now from here, we're going to go back up here. Now what I'm going to be doing is I'm going to be taking, I'm going to be taking the sum of the moments about point C. As you guys could see, I didn't draw out point C here in my drawing, but we know that the force of the bar CF and the force of the bar CD don't just affect point F and point D. We know that they are also both right here at point C, right here. So we know that they both lie on that point, meaning that they will not be creating a moment about that point, meaning that if we take the sum of the moments about point C, we'd be able to determine for the force of the bar GF. So that's what we're going to do right now. So taking this sign convention, counterclockwise positive, the sum of the moments about point C also have to equal 0. We know that these two will not be creating a moment. So from there, what do we have? We have our force of our bar GF. Now, as you guys can see, this is to an angle. So we know that there's going to be both a horizontal and vertical component to it. And because of that, that means that we have to determine a value for it. So what we're going to do is we're going to come and look at the dimensions that's given to us. What's given to us is that from here to here, we have a distance of 2 meters. So vertically, this has a distance of 2 meters. From there, we know from here to here has a distance of 4 meters. So if we were to go straight, this part has a distance of 4 meters. And because we know that, we could see we would be able to use the Pythagorean theorem, a squared plus b squared is equal to c squared, to be able to solve for our our I guess our hypotenuse side. So if we were to do that, we could simplify this down, and we know that this triangle has a slope of 1, 2, square root of 5. So that's how we determine that. So now that we know that, we could go back to now now taking the sum of the moments about point C. So going back over here, what I'm gonna do is I'm gonna be so we know that the force of the bar CF has both a horizontal and vertical component. We just need one of those to create a moment. So what I'm gonna do is I'm just gonna be doing the horizontal component of it. So since I assume that it's gonna be in tension, it is slanted to the left. So that means our horizontal component will be to the left. And to determine that horizontal component, we know that the force of the bar GF has to be multiplied by 2, since this is the horizontal component of the triangle, over the square root of 5, since that is the force. So let me write this out. We know that the force of the bar GF, but we're dealing with the horizontal component, so that has to multiply with 2 over the square root of 5. So that's going to be our force. That's our force right there. So from there, we know that moment is equal to the force times the distance. Since we're dealing with the horizontal component of it, and we're taking the sum of the moments about point C, we know that this right here would be our distance. So we have a distance of 4 meters. So times 4 meters. Now, is this a positive or a negative moment? Since I'm assuming that it's in tension, it is going to left in this example. So that means it's going to be creating that counterclockwise moment, meaning a positive moment. From there, we just have our two forces. So this one, we know it's going to be creating that clockwise moment. So negative moment. We have a force of 3 kilonewtons, and we know that here to here we have a distance of 4 meters. So let's write that out. So negative moment of a force of 3 kilonewtons times the distance of 4 meters. And then from there, we have our reaction right here. We know that this is going upwards, so that means it's going to be creating a counterclockwise moment about that point, meaning positive moment. And then from there, we know that we have a distance of 8 meters. So now we could go here. We have positive moment of a force of 4.75 kilonewtons times the distance of 8 meters. And we know that all of that has to equal 0. From there, we simply just solve for the force of the force of the bar GF. So the force of the bar GF comes out to have a value of negative 4.84 kilonewtons. Since we got a negative number, that means that we assumed incorrectly, meaning that this bar is actually going to be in compression. So now we have found two values of two bars. Now we're simply missing one bar. So we found CD and GF. So now we're just missing C of F. So from there, what I'm going to be doing is I'm going to be taking the sum of the moments I'm so sorry, the sum of the forces in the x direction. Because as you guys could see, both, just like GF, C of F also has a horizontal and vertical component since it is to an angle. So technically, you could also be taking the sum of the forces in the y direction, and you should still be getting the same answers. It doesn't matter. Just remember, if you're taking the sum of the forces in the y direction, you have to be including our three forces plus the value of C of F plus the vertical component of G of F, so that you would have to be doing all of them. Meanwhile, if we were to take the sum of the forces into the x direction, it would just be C of F and G of F. That's why I'm going to be taking the sum of the forces in the x direction. So sum of the forces in the x direction has to equal 0. So from there, we're going to look at our force of G of F. Remember, we're taking the sum of the forces in the x direction, so horizontal forces. We already determined the value of our bar GF, but remember, this is the value to it at an angle. We're trying to deal with the horizontal component of it. So to deal with the horizontal component, what are we going to do? We're going to be multiplying that force by 2 over the square root of 5, because once again, we're trying to work with that horizontal component of it. Since I assumed that it was in tension, it's going to be going to the left. So that means that it will be a negative force. So negative force. Even though we already know that it's in compression, you still have to deal the rest of your work with it being in tension, because your answer here already deals with how you guessed it incorrectly. So that's why it has that negative sign. So you guys could see that we will still be getting the same answer. So since we assumed intention in the beginning, and that's how we started off the problem, that's how you will continue the rest of the problem. Just make sure that for the rest of the work, you're including that negative sign that you got. So negative, it's going to be a negative force since we assume tension, so to the left. So we know that we have to multiply the negative 4.84 kilonewtons by 2 over the square root of 5, because we're trying to deal with the horizontal component of it only. Now from there, we're going to go back to our bar C of F. Once again, it is at an angle, so we're going to have to find the slope to it. As you guys could see, we know that this side of the this side of the triangle has a length of 4 meters. We know that this side of the triangle has a length of 4 meters. So again, using the Pythagorean theorem, a squared plus b squared is equal to c squared, we could see that this has a slope of, or is a triangle of a 1 square root of 2 triangle. Correct? So now, because of that, what we're going to be doing is that we're going to be multiplying the force of the bar CF by, we're going to be multiplying it by 1 over the square root of 2, since we want to deal with that horizontal component. Now, if you were to deal with the vertical component, it would also be 1 over the square root of 2, but that's simply just because it is a 1 square root of 2 triangle. Remember, I'm going to be using this one since we're dealing with the horizontal component of it. So since I assume that it's going to be in tension, it is slanted to the left. So once again, a negative force of the force of the bar CF. CF. Sorry, you guys. Just let me. And we know that we have to multiply that by 1 over the square root of 2 since since we're dealing with the horizontal component from it. And then from there, we have one more force. We know that our force of our bar CD is completely horizontal. So we could simply just, you don't have to multiply it by anything. We simply know that it has a value of 475. Since we assume that it's in tension, it is going to left. So once again, a negative force. So negative force of 4.75 kilonewtons. And we know that all of that has to equal 0. So now that you have all of this down, we're simply just going to solve for the force of the bar C of F. So if you do that, you would end up getting a value of negative 0.59 kilonewtons. Since we got a negative number, that means we assumed incorrectly. So that means that this bar is also going to be in compression. And with that, we are done with this example. So remember, for this example, it asked us to use the method of sections to evaluate the force. So the first step was to determine where that cut was going to be, um, where you would want it to cut to go through all those members or all those bars that you have to determine the force, which is why they cut it right here. From there, you want to evaluate each side of that truss to simply see which one would have less forces or less reactions that you have to deal with or find, which is why we went with the right side, since we would just have to find one reaction. From there, you would have to determine to calculate the force of that reaction. What you want to do is you want to take the sum of the moments about the point where the other two unknown reactions are. So you could simply just solve for this one. And then from there, you want to draw out your truss that you're going to be working with. And then from there, just simply use the method of sections to determine the values of those bars. Thank you guys so much for watching this video. Please feel free to give this video a thumbs up if you guys found this video useful. And please also feel free to subscribe to our channel if you guys would like to see more videos like this.